All right, so this is an example of the intersection of medians, also known as a Medicenter or centroid, and how to find them. So we have a coordinate plane, and we have three vertices with their coordinates written down. And so what we're going to do is we're going to take those coordinates to be able to find where the midpoint is of each side, and then take that midpoint and connect it up with the vertice opposite it. And that's going to create a line that we will call a median. And we'll do that for two sides and see where they intersect. So where the medians are for both of these and where they intersect will be the centroid. We could do it for all three, but it only takes two lines to form a point. So if we did for all three, we'd notice that they all intersect in the same spot. Two should be enough. So first thing is we need to find the midpoint of AC. That's the side I'm going to be working with. So the midpoint, I'll do capital M, of AC is going to be equal to the midpoint formula between those 2 points. So it's the average of the x's and the average of the y's. Well, it turns out the x's for A are 8, and the x's whoops, I goofed that up. 0 for A, and then 6 for C. The y's for A and C are going to be 8 and 4. There we go. And if we do some math, we get that the coordinate, the midpoint of those sides, is 6 divided by 2, which is 3, and 12 divided by 2, which is 6. So 3 comma 6 is the midpoint there. So if I go to 3 and go up 6, 1, 2, 3, 4, 5, 6, yep, that's on that line. There's the midpoint of AC, 3 comma 6. Now I want to connect that midpoint to this vertice to create a median. So to connect those 2 points, I need to find the equation of the line between those 2 points. And the way to do that is to find the slope between those 2 points. So finding the slope, which I will do with little m, the slope between M, big M, and B is going to be the rise over the run. So it's going to be the y's minus the x's. So if I do this, the y's for M right here is 6, and the x for M is 3. And if we subtract B's coordinates, 0 for y, 3 for x, we get our slope. And our slope for this line is going to be 6 minus 0, which is 6, over 3 minus 3, which is 0. So this is an undefined slope, which you should notice makes sense, because if we were to draw a line between here and here, it would be a vertical line, and vertical lines have undefined slope. So there's our median. The equation of that line is going to be not y equals, but x equals 3. And the reason for that is because this is a line where x is always 3. Here it's 3 comma 1, 3 comma 2, 3 comma 3, 3 comma 4, 3 comma 5, 3 comma 6. And y can be anything. So we don't know anything about y. All we know is x equals 3. So that's the line that connects the midpoint of AC to vertex B. Let's find the midpoint of AB and connect it to C. So the midpoint of AB, let's do that in blue, or let's not use blue. Let's do that in green. The midpoint of AB, which I'll do here, capital M for midpoint of AB, is going to be the average of the x's, comma, the average of the y's. A's x value is 0. B's x value is 3, so the average of the x's is there. The average of the y's, A's y value is 8, B's y value is 0. So we have 3 halves, comma, 8 over 2, which is 4. So 3 halves, comma, 4 is the midpoint of AB. And if I go up here to 3 halves, 1 half, 3 halves, go to 4, 1, 2, 3, 4, it is indeed on our segment, which is always a good sign. So that's the midpoint of AB. Now we want to find the line that connects this midpoint to C. So if you notice, if we were to draw this line right now, and I'll do it in, let's see, what color should I do? Maybe purple. No, not purple. No, let's do light green. You'll notice that this is a horizontal line. So think about what kind of slope a horizontal line has, but we can find it. The slope, which I'll do here, of the midpoint of AB and vertex C is going to be the y's over the x's. So the y's for The midpoint, well, that's going to be 4, and the x is going to be 3/2. The y for c is 4, and x is 6. So if we subtract those, we get 0 over 3/2 minus 6. So there are 12 halves in 6. Minus 3/2 minus 12 halves is going to be negative 9 halves. So all that matters here is that we have 0 over a fraction, which is 0. So our slope is 0. And when we have a line with the slope of 0, y equals 0x plus b, well, it turns out this goes away, and y just equals whatever our y-intercept is. So in this case, if you look at this line, the y-intercept of this line is going to be 1, 2, 3, 4. So the equation of that line is y equals 4. So where do these two lines intersect to form our Medicenter or centroid? Well, they intersect at the point where x is 3 and where y is 4. So they intersect at 3, 4, which if you check 1, 2, 3, 1, 2, 3, 4, that is our Medicenter. So our Medicenter is at 3, 4, also known as the centroid. When the lines aren't vertical and horizontal, then things get a little bit weirder. You get an equation for each. So instead of x equals 3, you'd get y equals mx plus b for this guy, and you'd get a y equals mx plus b for this guy, and you'd set them equal and find out where they intersect. And I'll do that in a separate video. So here's the first example, the intersection of medians. To find the centroid or the Medicenter, you find the midpoint of each of two sides and then connect them to their opposite vertices. Find the equation of those, set those equations equal, and where they are equal is where they intersect. If you happen to get vertical and horizontal lines like I had here, they give you the coordinate.